Today we're going to be learning about electron configuration. Electron configuration basically shows where the electrons probably are in an atom. Because electrons move in wave-like patterns, scientists don't know where exactly electrons are. So they use electron configuration to figure out where they think the electrons are or will be in an element. Okay, so the first thing we need to do is we need to label our orbitals. There are 4 orbitals, S, P, D, and F. The S orbital can hold 2 electrons, the P orbital can hold 6 electrons, the D orbital can hold 10 electrons, and the F orbital can hold 14 electrons. So we're going to do that, and we're going to do that on our periodic table. First, we're going to start with the S orbital. The S orbital is here. And it is also over here with helium. So we're going to mark that. S. Okay. The second orbital we're going to label is the D orbital. So the D orbital is right here. And the D orbital, again, can hold 10 electrons. And so we're going to mark that. D. Now we're going to move on to the P orbital. The P orbital is right here. And then we're going to mark that P. And then we're going to finally mark our F orbital. And the F orbital is all the way down here. Okay, so now we're going to go through and mark the different, I guess the different areas of the orbitals. So, for example, we'll do the S orbital. This is 1s, 2s, 3s, 4s, 5s, 6s, and 7s. So these are just the different sections, or I guess levels per se, of this orbital. So this right here, these two are going to be part of the S orbital, or the 1s orbital. These two are part of the 2s orbital. These two are part of the 3s. These two are part of the 4s, 5s, 6s, and 7s. So now we go to the D orbital, and we're going to label those. This one is a little bit more tricky because this starts at 3D, and so you have to remember that even though this is at 4s, this goes to 3D. So 3D, 4D, 5D, and 6D. And then for the P orbital, you have 2P, 3P, 4P, 5P, and 6P. And also down here is 7P. On many periodic tables, these spaces will be filled, but because this one doesn't have the filled spaces, it's just know that those are this row. If you have a periodic table with the spaces filled, it's still 7p, and if you don't, this one is also in 7p, if that makes sense. And then we're going to jump down to the f orbital. This is 4f and 5f. Okay, so the basic thing that you need to know when doing electron configuration is that it reads left to right, just like a book. So we're going to try tellurium, Te. We're going to do the shorthand and longhand. So first we're going to do with the long because I want you to be able to see the whole thing, and then I'll show you a shortcut. So Te, that's what we're going to do. So Te equals, and Te is, let's see, right here at 52. So there he is right there. Okay, so the first thing, we always have to start off, because we go left to right, we need to start off right up here. So if we look, we're going to read this book all the way down, keep going, all the way down to here. So we have to read the orbitals. So the first orbital that we see is 1s. So you're going to go ahead and write that down. So how many do you see in that 1s orbital? You see 1, 1, 2. So you're just going to put 1s, 2. Then you jump down. So you're reading the book, you go jump down, and you see that it's 2s is the next orbital. So 2s. And you count how many are in that orbital. Well, you see 1, 2. So you put 2s, 2. And then you jump over, and you see that we've switched. Well, what is this? This is 2p. So we're going to write 2p and count. 1, 2, 3, 4, 5, 6. So you write that in. Now we're going to jump down the next line, and you see we're at 3s now. So this is 3s. So we're going to write 3s, and then we're going to count. There's 1, 2, and 3s. Then we're going to jump over, and we see that it's 3p. So we're going to write 3p. Then we're going to count. 1, 2, 3, 4, 5, 6. Then we go down to the next line. The next line is 4s. So we write 4s. And then we count. 1, 2. There's 2 of them in the 4s. Now we jump over. We see that the next section is 3d. So we're going to write 3d. And then we're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to write in 10. Then we jump over. Oh, that does not look like a 10, so we'll just fill in that 0. Okay, jump over, and we're at 4p. So we write 4p and count. 1, 2, 3, 4, 5, 6. Write the 6 in. Now we're going to jump down, and we see that the next thing that we have to do is 5s. So we write 5s, and then we're going to count. 1, 2. So we write in the 2, and we jump over to 4d. So we write in 4d. Then we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we write 10. And now we jump over to 5p. So we write in I'm going to jump down here, 5p. And then we count 1, 2, 3, 4. And so we've gotten to the element that we are looking for. So this is the electron configuration in the long version for tellurium. So, but as you can see, it kind of starts getting repetitive because you see how there was 10 here, and then 10 in the 40 section, and then there were 6 in the 2p, 3p, 4p, and then 2 in the 1s, 2s, 3s, 4s, and 5s. Well, there's an answer. We can do the shorthand version. So for the shorthand version, we're going to do, hold on, let me erase some of this really quick. Okay, so I'm just going to fill in these, or label these orbitals back again so you can see them. But for the shorthand version, we're going to look at the noble gases. So the noble gases are located right here. These right here are the noble gases, and they're going to help you out a lot because they help us do the shorthand version. So what we do for the shorthand version is we go and we look at the closest, I'm going to label our element that we're looking for again. It is right here. There we go. So as I was saying, what we do for the shorthand version is we look at the noble gases, the noble gas that came before our element. So if we look, this is not the noble gas that we're looking for because it comes after. We're looking for the one that comes before. So we go all the way back up, and then we come back around, and we see that it is krypton. This is the noble gas that we're going to use. So what we notice is that if we were to look at the electron configuration for krypton, we would see that it's the same. It's going to be the same as part of the ones for the element that we're looking for, Te. So why do we need to write that out? We don't. That's insane. So Te equals, make sure to add your brackets. You're going to put that noble gas that you found that comes before your element in brackets. And that's going to tell people that it's the same electron configuration, or the electron configuration that comes before the part that you're going to write here is the same as krypton. And so they're going to know, okay, if I need to look at the longhand version, I'm just going to go back and do the electron configuration for krypton and then add this part that we're about to do. So now all that you have to do is go down to the next line and see that it's 5s. So you write 5s and you count. And we know that that's 2. Then we jump over and we do 4D, just like we were doing up there, and we count, and we know that that is 10. And then we go over here to 5P, and we know that that is 4. And there's the shorthand version for tellurium. And so there's the longhand and the shorthand versions of the electron configuration for the element Te. I hope this helped, and I think that is all. Thank you, and again, I hope this helped.